Hello friends, this is Animes and welcome to the GATE mantra. So in last video we have completed the marks, okay, and we have also seen the question related to the multiplexer. So in this video we are going to start with the new topic, that is demultiplexer, okay. In this video we are going to start with demultiplexer. So multiplexer, demultiplexer is also a combinational circuit which uh, is used to convert one input to the many output, okay. So what is the multiplexer? The multiplexer is a combinational circuit. What is multiplexer? It is a combinational circuit it is a combinational circuit which in which it is a combinational circuit in which one input in which there is a one input and many output. So demultiplexer is also a combinational circuit in which one input in which there is one input in which there is one input and multiple output or many outputs. So and this input is transferred to the output. This input is transferred to the one of the many output depending upon the selective line, okay, depending upon the selective line. So this input is transfer you can say transfer to one of the many output, okay, depending upon selective lines. So what is the demultiplexer? Demultiplexer is also a combinational circuit in which there is a one input and there is a many output, and the one input is transferred to the one of the many input depending upon the selective line, okay. So like this is the one input and here is many output and here is selective line, okay. So if there is an n selective line, there will be 2 to power n output and there is only single input, okay. This is the input and these all are the output, okay. These all are the output. So we can say that this is the one input, okay, and there is many output. There is many output, like this is O1, O2, O3, and this is, okay, this is ON, okay, and this input is transferred to the one of the many output depending upon the selective line. Depending upon the selective line, it will be connecting to the many of the output, okay. Okay, then let's go for the 1:2 demultiplexer, okay. So here is 1:2 demarks, okay. So 1:2 demarks. So here is it's have the one input and it's have the two outputs and only one selective line. Okay. So here is the input IN and here is the output. Okay, and this is 1 to 2 demax. Okay, this is 1 to 2, 1 to 2 demax. So here we have to write the truth table, right? And make it y0 or y1. Make it y0 and y1. So here is the two output and one input, and there is one selective line. Okay. Now the truth table. Now we will write the truth table. This is the S. Okay, and this is the y0, and this is the y1, and this is the y0. Okay. So if selective line is 0, then I0, then I1, then this input in, okay, that this input in is connected to the Y0. So Y0 will be equal to the in. Y0 will be equal to the in. And if, and this will be the 0, and if selective line is 1, then this in is connected to the y1, then this in is connected to the y1, and the output y0 will be equal to 0. Okay, this is the our truth table. So we can write the Boolean expression from our truth table that y1 will be equal to, see here what will be the truth table, y1 for 0, okay, for selective line 0, y1 will be equal to 0, and for selective line 1, y0 will be equal to 0 and y1 equal to the 1. Okay, so y1 is equal to S and the I in, okay, and y0 will be equal to the S bar and the I in, right? Okay, so this is the 1:2 demux, right? In which there is a one input and there is a two output, y0 and the y1, and this is the truth table. For selective line equal to 0, in will be transferred to the y0, and for selective line will be for selective line 1, in will be transferred to the y1. Okay, and this is the what is truth table. Okay, so let's see that 1:4 demux. Okay, 1:4 demux. Let's see the 1:4 demux. So first make here. Okay, there will be the single input and there will be 4 output. This is y0, y1, y2 and y3, and this is the I. Okay, this is the 1:4 demux. Okay, so truth table, and there will be the two selective line. Okay, there will be two selective line, S1 and S0. Okay, so if the selective line will be equal to 0, 0, if the selective line will be 0, 0, then this input I will be transferred to the y0, and for the selective line 0, 1, this I will be transferred to the y1, and for the selective line 1, 0, this I will be transferred to the y2, and for the selective line 1, 1, this I will be transferred to the y3. Okay, so we will write the truth table here. Okay, we will write the truth table here. Here this is the two selective line, S1 and S0, and here will be the output, that is y3, y2, y1 and y0. Okay, 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 so for 0 0, for 0 0, y naught will be equal to I and all will be 0. Okay, for 0 1, for 0 1, for 0 1, this y1 will be equal to I and all will be 0. Okay, for 1 0, for 1 0, this y2 will be equal to the I and all will be 0. Right, and for 1 1, this y3 will be equal to y and all will be 0. So from here we can see that what is the y3? What is the y3? Y3 will be equal to S1 and S0 and I. Okay, so let's start with the y0. The y0 will be equal to S bar and S0 bar and the I. Then this will be the S1 bar, S0 bar and the I. What will be the y2? Sorry, y1. Y1 will be here. Y1 will be S1 bar and the S0. Okay, S1 bar and the S0 and the I. What is the y2? Y2 will be here. This is the S1 and S0 bar. This is the S1 and S0 bar and the I. Okay, S1 and S0 bar and the I. And what will be the y3? Y3 will be the S1 and S0 and the I. Okay, so this is the 1:4 demultiplexer. Okay, 1:4, 1:4 demultiplexer where there is one input and there is a 4 output and there is a 2 selective line. And for selective line 0 0, this I will be transferred to the y0. For selective line 0 1, this I will be transferred to the y1. And for 1 0, this I will be transferred to the y2. And for 1 1, this I will be transferred to the y3. So here we have seen the 1:2 demux and 1:4 demux. Okay, and we have also seen what is the definition of the demultiplexer. And please draw the logic diagram. Okay, gate level logic diagram by yourself. Okay, by using the logic gate, using the NOT gate and the AND gate. Now we are see how we are going to construct the higher level demultiplexer by using the lower level demultiplexer. Okay. Now we will see how we are going to construct the higher level demultiplexer by using the lower level demultiplexer. So here we will see how we are going to construct the 1 to 16 demux using the 2 to 1 demux and 8 to 1 demux using the 2 to 1 demux like this. Okay, like same we have seen in the multiplexer. There is the same method. Okay, so construct. So construct, okay, 1:8 demux using 1:2 demux. So construct 1:8 demux using the 1:2 demux. So and this will be same as the multiplexer. Okay, this will be the same as the multiplexer. So first we will write here. Okay, first we will write here. Okay, 1:8 demux. Okay, using 1:2 demux. Okay, we will write this here. Then second step, we will convert it into the multiplexer. Okay, or not converting, we will write like the multiplexer. So we will write here 8 to 1 multiplexer and we will write here 2 to 1 multiplexer. Okay, and we will write, okay, and then from here we will write how many 2:1 multiplexer will be required to construct the 8:1 multiplexer. So for constructing the 8:1 multiplexer, there will be the 8 input, and for getting the 8 input we require the 4 mux. Okay, there will be 2 input here, 2 input here, 2 input here, and 2 input here, and then there will be the 4 output of this 4 mux. So for this we have to write here 2 mux, and there will be the 2 output. So for this we have to write here one more mux, and then we will get the answer here. If we want to construct it by using the multiplexer, in the same way we will construct using the demultiplexer. So if it's given the question that construct the 1:8 demux using the 1:2 demux, so we will convert it into the multiplexer, the 8:1 mux. Okay, and 2:1 mux. So how many 2:1 mux is required to construct the 8:1 mux? In this step it's required the 4, here it required 2, and here it requires 1. So total 7 mux required. Okay, 7 mux required. So but here we have constructed the 8:1 mux using the 2:1 mux, and here our target is to construct the 1:8 mux using the 1:2 mux. Okay, so for this we will write, okay, we need the 8 output. Okay, so we will write the 4 demux here, 4 demux here, in which there will be 2 output from each of the demux. Okay, and there will be the one input for these 2 demux. Okay, and for these 2 demux we require, okay, we require 2 1:2 demux. We require 2 1:2 demux, and here its input will be 1 and this input will be 1, and here we require again 1:2 demux. So here is our input I. Okay, and here is our final output y0, y1, y2, y3, y4, y5, y6, and y7. And the most important part is how we are going to provide the selective signal. So here will be S1, and here will be S2. Okay, here will be S1, and here will be S0. Okay, and this is the 2 to 1, sorry, 1 to 2 demux, 1 to 2 demux, and these all are 1:2 demux, 1:2 demux. Okay, and these all are 1:2 demux. So there is a way, so this is the way from which we can construct the 1:8 demux using the 1:2 demux. Okay, so for solving this for objective problem, we will convert this into mux, and then we will write simply this 4. For first stage we require 4 input. Okay, we require 4 2 to 1 mux because we require the 8 input here. For 8 input from the 2 to 1 mux we require 4 mux, and the 4 mux will provide the 4 output. So for this 4 output we need to fed into the 2:1 mux, so we require 2 2:1 mux. Okay, and the output of those 2 mux will be fed into the 1 2:1 mux, so we require here 1 mux. So total there will be the 4 mux, 7 mux, or for constructing this we will write there will be the 7 demux required. Okay, see here 4 in this stage, 4 demux. Here we require 2 demux. Here we require the 2 demux. Okay, and here we will require the 1 demux. The total we will have to provide the 7 demux. Right. So in same way, if we have to construct, okay, in same way, if we have to construct, okay, 1:16 demux using 1:2 demux. So how many demux will be required? So here it required 8. Okay, for getting this, first we will convert it into the mux, okay, then 60 into 1 and it will be 2 is to 1. So for getting the 60 input in the first state, we need 2 into 1 mux, we require the 8 mux in the first state, then we require the 4 mux into the second state, and we require 2 mux in the third state, and then we require the 1 mux into the last state. So total will be 8 plus 12 and plus 2 14, and total will be 15 mux will require, and for this case there will be the total 15 demux required, right? Just simply divide it, okay, just 16 divided by 2, what will be the answer? 8, okay, and now this 8 divided by 2, what will be the answer? 4. Now this 4 divided by 2, what will be the answer? 2, and this 2 divided by 2, what will be the answer? 1, okay, 1. So here total 8 plus 4 plus 2 and plus 1, total will be 15, right? Like this we will going to solve this, okay. Okay, now here we have completed the demultiplexer. Okay, there will be the less question from demultiplexer, or there will be no any question from demultiplexer in the GATE or the ESE. Now we are going to cover the most important topic of the combinational circuit, that is decoder. Okay, that is decoder. So what is decoder? So decoder is a combinational circuit like mux, demux, okay, in which there will be the many input and there will be the many output. Okay, there will be the many inputs and output in the demultiplexer. So we can define like the non-demultiplexer in the decoder. So we will define like the decoder is a combinational circuit in which there will be the many input as well as the output, right? So we will start with the decoder. Okay. So what is decoder? So as I have said already, the decoder is a combinational circuit in which there will be the many input as well as many output. Okay, and decoder, what decoder can do? So a decoder can convert any binary into the any decimal number. Okay, binary into the any decimal number. Okay, so decoder, what is decoder? It is a combinational circuit. It is a combinational circuit, okay, in which there are many input and many output. Okay, so from decoder what we will do? So we can use decoder as to convert, okay, to convert binary into any binary code into the any code, okay, into the any code. So for example, we can use the decoder, okay, the decoder to convert, okay, the binary, okay, the binary into octal. So to convert binary into octal, we use 3:8 decoder. Okay, so second is we have to, for converting the BCD into decimal, we use 4:10 decoder. and to convert BCD into hexadecimal, we use 4:16 decoder. So we have seen the definition of the decoder, that what is the decoder, and we have also seen what is the use of the decoder. Okay, what is the use of the decoder? Now we will see that how many decoder. Okay, so there are what is the type of decoder. So we will see there is the two type of the decoder. Okay, there is two type of decoder. So there are two type of decoder. First is active high decoder, and the second one is active low decoder. So what is the active high and the active low decoder? We are going to see one by one. Okay, that what is the active high decoder and what is the active low decoder. Okay, so first we will see, okay, the 2 to 4 decoder in active high. Okay, in active high. So this decoder is the important topic, okay, in the combinational circuit for the GATE as well as ESE examination. Right. So first we will see 2:4 decoder, okay, with active high output. So 2 to 4, 2 to 4 decoder, okay, with active high output. Okay. So first we will see 2 to 4 decoder. Okay. So in 2 to 4 decoder, the block diagram is like this. Here there is a 2 input. Here there is a 2 input, and here there is a 4 output. Okay, there is a 4 output. So here there is a 2 input I0, I1, and there is a 4 output B0, B1, D2, and the D3. And here we will see the 2 input as A and the B. Okay, and this is the 2 to 4 decoder. Okay, 2 to 4 decoder. Right. So there is no selective signal like multiplexer and demultiplexer. There will be no any selective signal. Okay. Right. So now we need to write the truth table of this 2 to 4 DMUX. Okay. Truth table of these 2 to 4 DMUX. So we will see there will be the 2 input A and the B, and there will be the 4 output D0, right here D3, D2, D1, and the D0, right. So, and there is also a enable signal, okay, because it is the active high 2 to 4 DMUX, so there is also a enable signal. This is the E, okay, and there will be also a enable signal E, okay, E. So if enable will be low, okay, if enable will be 0, then whatever will be the A and B, the output will be 0. Okay, the output will be 0. Now if enable will be equal to 1, and if the input will be 0 0, then this D0 will be selected and all will be 0 0, and this enable will be 1, and if input is 0 1, then this D1 will be selected. Okay, this D1 will be selected and all will be 0 0. Now this enable will be 1, and if 1 0 is our input, then this D2 will be selected, okay, and all will be 0 0. Now if 1 will be input, then this D3 will be selected and all will be 0 0. This is our truth table. Okay, this is the truth table of the 2:4 decoder. So 2:4 decoder, if the enable will be 0 with active high output. Okay, so if the enable will be 0, then what will be the whatever will be the input A and B, the output will be 0. Okay, the output will be 0. So if enable will be 1, if enable will be 1, then this 2:4 decoder will be work. And if A enable will be 1 and AB will be equal to 0 0, then this D naught will be selected, right? If the AB will be equal to the 0 1, then this D1 will be selected. And if the input will be equal to 1 0, this AB will be equal to the 1 0, then this D2 will be selected. And if the this AB will be equal to 1 1, then this D3 will be selected, in which A will be the MSB and the B will be the LSB. This will be the MSB, A will be the MSB. So we are going to write the Boolean equation, okay, expression, logic expression, Boolean logic expression for this D2, D3, D1, D0. Okay, so first we will start with the D naught. Okay, for D naught, this will be the one, and for this case when AB will be equal to 0 0, and for all the other case this is 0. So D naught will be equal to A bar and the B bar, A bar and the B bar and the E, right? D1 is selected when D1 will be selected. Okay, for all the case it will be equal to 0, and D1 will be selected if the AB will be 0 and 1, right? So D1 will be equal to A bar, B and E. Similarly, D2 will be selected when our input A and B will be equal to 1 0. So D2 will be equal to A, B bar and the E. Now D3 will be selected, D3 will be selected, okay, if our AB will be equal to 1 and 1, okay, 1 and 1. So here will be the A and the B and the E. So this is the Boolean logic expression of our output, okay, D0, D1, D2 and D3, right? Okay, so by using the logic gate, you will be get this D0, D1, D2 and the D3. Okay, we will give the two signal A, B and E, and we will get this D0, D1, D2 and the D3, right? D0, D1, D2 and the D3. Okay, so now we are going to see, okay, the active low, okay, active low output decoder, okay, active low output decoder. Okay, so I will write here, okay, I will write here only. Okay, 2 to 4 decoder, okay, with active low output, okay, with active low output. So first we will write the block diagram of the 2 to 4 decoder here. Okay, 2 to 4 decoder here. Okay, here will be the two input, okay, I0 and I1, and here will be the 4 output, okay, D0, D1, D2 and the D3, okay, right? And here we will provide the A and the B, where A will be MSB, okay, and B will be LSB, okay, and B will be the LSB, and A will be the MSB, right? Okay, now what we will do in the active low, and there will be also enable signal, okay, E, okay. So what we will do in the active low output, we will use the NOT gate, okay, add the output of the decoder, okay. So if we will select the output 0 0, sorry, if you will select the AB, okay, that will be the two input of the decoder as the 00, okay, as the 00, then this D naught will be selected, okay, and the expression for D naught will be equal to A plus B, okay, and the expression for this D1 will be equal to, okay, A plus B, okay, if A B will be 00, then this one will be selected. If AB will be 01, okay, 01, then this one will be selected, D1. If input will be equal to AB will be equal to 10, then D2 will be selected and expression for D2 will be A bar plus B, and if the input will be 11, AB will be the 11, then this D3 will be selected and expression for this is A bar and the B bar, okay. So this is the 224 decoder, okay, 224 decoder with active low output decoder, okay. So if AB will be 00, this if AB will be 00, then this D naught will be selected. If AB will be 01, then D1 will be selected. If 10, then D2, and if 11, then D3, okay. And here the expression for D naught will be A bar, and this E, remember, this E will be equal to 1, okay, this E will be equal to 1, then this decoder will be work, okay, this E will be the 1, then this 2 is to 4 active high decoder will be work, or if E will be equal to 1, then this active low decoder will be work, okay. So for 00, D naught will be selected and all will be 0. For 01, this D1 will be selected and all will be 0. For 10, this D2 will be selected and all will be 0. And for this 11, for input 11, this D3 will be selected and all will be not selected, okay. So the expression for this is D naught A plus B, D1 A plus B bar, D2 A bar plus B, and D3 A bar plus B bar. So here we can see that, okay, here we can see that here the expression will be A bar B bar, A bar B, A B bar, and A B. So from these two expression, what we will see from these two expression, from the expression of the output of the 2:4 demultiplexer using the with the active high and the active low, we will see the output of the 2:4 decoder with active high output. The output will be the min term. The output will be the min term, and here the output will be the max term. Here the input will be the min term, so we can say that the output of the 2:4 decoder with the active high will be give the output as a min term, and the 2:4 decoder with active low output will give the output as the max term, okay, max term, right. So after I hope this will be the clear to all of you, okay. After that we are going to see how we can construct the higher order decoder using the lower order decoder, right, using the lower order decoder. So first let me erase this. So here we will see how we are going to implement the higher order decoder using the lower order decoder, okay. So implementation of higher order decoder, okay, higher order decoder using lower order or low order decoder. So we can say here that, okay, we can say here that the internal structure of the decoder as well as the demux will be same. Okay, we can say the internal structure of this decoder and the demux will be same. So if it will say that implement, okay, implement or construct, okay, or construct, okay, construct 4:16 decoder using, okay, using 2:4 decoder. If the question will be this construct the higher order decoder, that is the 4:16 decoder using the 2:4 decoder. So to solve this type of problem, first we will write, okay, 4:16 decoder, okay, and by using 2:4 decoder, and we know that the internal structure of this decoder and the demux will be same. So we will write, okay, we will write this 4:16 decoder as 1:16 demux, and we can write this 2:4 decoder as 1:4 demux. Okay, observe here, 4:16 decoder can also, we can say 4:16 decoder as the 1:16 demux and 2:4 decoder as 1:4 demux, right? Okay, then for 1:16 demux we can also say it 16:1 multiplexer, 16:1 multiplexer, and we can say here 4:1 multiplexer, and we are good enough to solve that how we can construct the 16:1 multiplexer using the 4:1 multiplexer. So for constructing it, how many multiplexer we require? So 16 divided by 4, okay, plus 4 divided by 4, okay, this will be equal to 4 plus 1 will be equal to 5. So 5 mux will be required. So 5 mux will be required to construct the 16:1 mux using the 4:1 mux. So the 5 demux is also required to construct the 1:16 demux using 1:4 demux. Observe that what I am saying. So in same 5 decoder, okay, 5 decoder, okay, which decoder? 2:4 decoder, okay, 5 2:4 decoder is required to construct, okay, 4:16 decoder. Okay, so for observe here, for solving this type of problem, please remember one thing, that the internal structure of the decoder and demux is same. So for 4:16 decoder we can write it as 1:16 demux, and 2:4 decoder we can write it as 1:4 demux. So 1:16 demux we can write it as 16:1 demux for only solving the question, okay, for only solving the question in the GATE, okay, and for 1:4 demux we will write it as 4:1 demux. This is we are doing for solving the question, okay. This doesn't mean that 1:16 demux will be same as the 16:1 demux, right? Because here is the 16 output, here is the 16 input, okay, and or these two are the opposite. For solving only the question we are doing like that. Okay, so 16 is to 1 marks, and this is a 4 into 1 marks. So how many 4 is to 1 marks is required to construct the 16 into 1 marks? This will be the, we require the 4 is to 1 marks in the first stage, and the 4 is to 1 marks into the second stage for constructing the 16 into 1 marks using the 4 is to 1 marks, right? So in this way we are going to solve this type of the problem, right? Now we can also make the block diagram here, that how we are going to construct this, okay, this 4 to 16 decoder using 2 to 4 decoder, right? Let's see the block diagram quickly, because no one will tell you to draw the block diagram into the GATE examination. Okay, only they will ask the question like how many 2 to 4 decoder will be required to construct the 4 to 16 decoder, and for doing this we will do like this shortcut, and we will write total 5 decoder will be required. Okay, right? Now we will be going to ask the block diagram, right? So we will use in the first step, okay, we will read and use this 2 to 4 decoder, where there will be the 2 input and there will be the 4 output. Okay, there will be a 2 input A and the B, and here is the enable E. Okay, and there will be the 4 output. Now we are going to use the 4 decoder here. Okay, this 4 2 to 4 decoder. Okay, so see here we will pin outputted y1, y2, y2, y3, y0, y1, y2, y3. Okay, here will be y4, y5, y6, y7, y8, y9, y10, y11, y12, y13, y14, and y15. Total there will be the 16 output. Total there will be the 16 output, because we are going to we have constructed this 4 to 16 decoder using 2 to 4 decoder, and there will be the 2 to 4 decoder. Now what we are going to do, we can write this C and the D, C and the D, C and the D, and C and the D, and here enable, and enable. So we are going to use this enable like this. Okay. So here we will make the enable will be equal to 1. So if A and the B will be equal to 0, 0, if A and the B will be equal to 0, 0, then this D naught will be activated, and if D naught will be activated, then all these 3 decoder will be deactivated, and only this decoder will be activated. And for changing the C and D, the y0, y1, y2, and the y3 will be selected. So for all this output, A and B will be equal to 0, 0, A and B will be equal to 0, 0, and for changing C and D, where A will be the MSB and D will be the LSB. Okay, D will be the LSB and the A will be MSB, right? So for A and B 0, 0, this decoder will be selected. Okay, write here the name. We are writing here the name. This is the D naught. Okay, this is the D1, D2, D3, and the D4. Okay, so for AB will be equal to 0, 0. This D1 will be selected. This D1 will be selected. Why this D1 will be selected? Decoder 1 will be selected because for input 0, 0, this D naught will be activated. This D naught output will be activated, and due to that this first decoder will be selected, and we are changing the C and D. We are changing C and D. So for C and D 0 0, this y0 will be selected. For C and D 0 1, this y1 will be selected. For C and D 1 0, this y2 will be selected, and for C and D 1 1, this y3 will be selected. Similarly, for the input 0 and the 1, AB will be 0 1, this decoder 2 will be selected. For 0 and 1, this decoder 2 will be selected, and for CD 0 0 0 1, okay, 1 0 and the 1. Similarly, for the input 1 0, this D3 will be selected. For the 1 0, this D3 will be selected, and C and D will be 0 0 0 1 1 0 and 1 1. And for input A and B 1 1, this D4 will be selected. For 1 1, this D4 will be selected, and we will change this C and D. Okay, we will change this C and D, right? So we can write here as A bar, B bar. Since this is the active high decoder, A bar, C bar and D bar, we will write here A bar, B bar, C bar and D. We will write here A bar, B bar, C and D bar. We will write here A bar, B bar and C and D. Similarly, we will write for all this. Okay. So in this way, we can construct the 4 to 16 decoder using 2 to 4 decoder, right? So total will be, there will be the 5 decoder needed. Okay, 4 in this state, 4 decoder, and 1 decoder here, 1 decoder. So total 5 decoder. Total 5 decoder needed, right? Total 5 decoder is needed. Okay, similarly we can solve all the other problems like how many decoder, this decoder, 5 is to 32 decoder, how many this 2 to 4 decoder required to construct this 5 is to 4 decoder, 5 is to 32 decoder. Okay, so we will write like the demux. Okay, we will write like the demux. We can write it 5 is to 32 decoder, write 1 is to 32 demux. Okay, and we can write 1 into 32 demux like 32 to 1 mux. Similarly, we can write this 2 to 4 decoder as 1 to 4 demux, and we can write this 1 to 4 demux as 4 to 1 mux. This is only we are doing for solving the program. Okay, there is no any concept that 4 is to 1 mux will be same as the 1 into 4 demux. The internal security all will be different, right? The input output will be also different. Okay, so how many 4 is to 1 mux is required to construct the 32 to 1 mux? So here we require 32 divided by 4 plus 8 divided by 4. Okay, 8 divided by 4 and plus, so there here 32 divided by 4, 8 mux here required and 2 mux here required. Okay, and plus 1 mux here required. So total 11 mux required. 11 mux required. Or total 11 decoder required. Total 11 decoder, 2 to 4 decoder required to convert this 5 to 32 decoder. Okay, 8 here and 2 here and 1 here. Okay. Okay, let's see the another example. Okay, let's see the another example. So construct 3 to 8 decoder, okay, using 2 to 4 decoder. So the question is construct 3 to 8 decoder using 2 to 4 decoder. So how many 2 to 4 decoder is required to construct the 3 to 8 decoder, right? 3 to 8 decoder. So we are going to solve this, okay? We are going to draw the block diagram and we are going to solve it. So here 2 to 4 decoder, okay? So we will write here 1 2 to 4 decoder, and we will write here second 2 to 4 decoder. We will give the input, okay, 2 input here, 2 input here, and we will give 4 output here and the 4 output here, right? This is the 2 to 4 decoder. This is also 2 to 4 decoder, right? And here will be enable and here will be the enable, right? Okay. And here this is the D note, D1, D2 and D3. We have D4, D5 and D6, D7. Okay. So this is there is a 8 output and there is the 4 input. Okay. And we require only 2 to 4 decoder. How much required to get the 3 to 8 decoder? So here we will require the 3 input and 8 output. So here we have constructed the 8 output, but how we will construct the 3 input here? So for doing that, okay, see, if we are writing here LSB, okay, this is B and this is C, okay, this is B and this is C, and C will be our LSB and A will be our MSB. So if we will provide this, okay, we will provide this enable, this enable. So if we provide this enable, so if we will provide this enable as a signal 1, we will provide 1 at this enable, so this decoder will be work. And at same time, if we provide this enable 0, this decoder will be not work, right? So at a time we want here, at a time only one decoder should work, so that if we apply B and C with any other input, and this output will be come, like this output will be open. So here we will be applying our MSBA. Here we will apply our MSBA. Okay. Here we will apply our MSBA. So for A will be equal to 0. This is MSB. So for A will be equal to 0. This decoder should work and this decoder should not work. So we will add like this. See. So if this A will be equal to 0, then this decoder will be work and this decoder will not work. This decoder will not work. So for A will be 0, for A will be 0, for A will be 0, we will write A here and BC for changing BC. So for B will be equal to, right here B is this and C this, okay. B and this, we will write this as LSB, C as LSB. That was also true, this is also true, right? So if B and C will be 0 0, if B and C will be 0 0, then this D note will be selected, okay, this D note will be selected, okay. And if B and C will be 0 1, then this D1 will be selected. If B and C will be 1 0, then this D2 will be selected. And if B and C will be 1 1, then this D3 will be selected, okay. And if the A will be 1 and if A will be equal to 1, then again 0 will be here and 1 will be here. Now this decoder will be not work and this decoder will be work. So for A will be 1, this decoder will be work. For A will be 1, this decoder will be work. And this B for changing the B and C, we will be changing the output. Okay, D4, D5, D6 and the D7. So for B and C 0 0, this is 0 1. For 0 1, D5 will be selected, and P1 0 D6 and P1 this. Okay. So we can write the expression here. Output is expression. Okay, like this. This is the A bar, B bar, C bar. This is the A bar, B bar, C. This is the A bar, B, C bar, and this is the A bar, B and C. This is the A, B bar, C bar. This is the A, B bar, C. This is A, B, C bar, and this is A, B and C. So we have made here 3 to 8 decoder using the 2 to 4 decoder. So how many 2 to 4 decoder will be required to make to construct the 3 to 8 decoder? So here total 2, okay, 2 to 4 decoder required. Total 2 to 4 decoder is required. Right. Similarly, one question for do. Okay, one question. If you want to do it by yourself. That how many 2 to 4 or how many this 3 to 8 decoder required to construct 4 to 16 decoder. Do it yourself. Okay, just do it yourself. And if you will fill the out, please ask into our Telegram channel, or we can also comment into the comment section. Okay, for this question. Okay, and I have solved this question. Okay, very clearly. If there will be any doubt, please replay the video and see once again. Okay, so almost this decoder is completed. And only the problems is remaining, right? And decoder is completed. So we will do some problem from the GATE previous year, as well also we will do some problems of advanced level problem that I will give you from my side. Okay, and after completing this decoder, okay, we will complete like 4 to 5 questions. Okay, then we will go into the encoder. We will go to the encoder. Okay. Thank you for attending the classes. Okay, thank you.